think here we should learn the already we discussed the so many concepts. Now we will discuss the another important concepts in the subject point of view, okay, as well as knowledge point of view, of course. Okay, how to create a chatbot is a challenge, of course. Okay, how to create a chatbot is a challenge. Creation of a chatbot is a challenge, no doubt on that. Okay, now we'll discuss chatbots are not meant for one application. It's meant for multiple applications, of course. There are multiple applications are there for chatbots. Not ended with a single application, of course. Okay. Now let us be see in the problematic way. Okay, about this. Already we learned the so many concepts. Now we want to apply. That is the role of the today's presentation. Today's presentation is our role is to application the chatbot design, architecture and application. Chatbot design, architecture and applications. This is the theme I'm posting on the chat box, of course. Chatbot design, architecture and applications that we have to learn. Of course, it's a very interesting topic, of course. Okay. Now we will learn one by one. The first of all, I want to before sharing my presentation, I am telling that a chatbot is also known as a dialogue system or conversational agent. Okay, a conversational agent is a computer program that can intimate a conversation with a user. This is the concept of chatbot. This is simply an agent. In the so many decades onwards, chatbot technology is evolved tremendously thanks to growing popularity of artificial intelligence and machine learning. Chatbots are proving themselves as a valuable tool in many situations and are visible in almost every aspect of our daily lives. Okay, in this we should learn the design, architecture and applications of chatbots. We will discuss the evaluation of chatbots, present a technical overview of the chatbot system and technology and support, and address the applications and potential implications of chatbot wider world. Okay, now we will discuss one by one. I will share my screen now because I discussed a wonderful concepts for you. Now I will share my screen. It is very interesting for all of you. Each and every point is. Okay, now I will share my screen. First, I will start from introduction onwards. Then I will discuss about overview of the chatbots, of course. Okay. My screen I will share. So this is the thing. Introduction, overview of the chatbots. You can make a grip on that. On that, the subpoints is the rise of chatbots, classification of chatbots, design principles, rule-based chatbots, machine learning, architecture, user interface, natural language understanding, slot filling, statistical approaches of the natural language. Okay, so dialogue management, design issues, hand crafted approaches. Okay, statistical approaches, response generation system, applications to the future outlook. Okay, so Google, Microsoft, like that. Okay, so now in the introduction, I want to give a brief regarding to that introduction part. A dialogue system is an example, an intelligent agent that intends to hold natural conversations with humans. More specifically, it is a software application with the help of natural language processing and machine learning that simulates human conversation in natural language via text uh, or text to speech. Dialogue systems have come to a long way since their inception in the 1960s. Both the hardware and software aspects of computer science and natural language processing and machine learning techniques have developed tremendously thanks to the advancement of these emerging technologies. Chatbots have evolved from systems that generate machine-like responses to human-like agents capable of developing long-term relationships with the users. Okay, so modern chatbots includes Apple's Siri and Amazon's Alexa and Microsoft's other things. Chatbots premises a range of potential benefits. Most notably, they provide a responses and solutions that are instant, constant, and reliable. These characteristics make a chatbot a powerful tool in many different areas, and their use has evolved rapidly in the fields such as business, e-commerce, and healthcare. So please try to understand these are the fields very demanding of the chatbot. Requirement is very demanding. I want to post those areas in the chat box. Okay, these areas are very demanding: business, e-commerce, and healthcare. Okay, so here overview of the chatbots, the rise of chat, the idea of chatbot inspired. Okay, so here you should see in this way. Okay, this is a conversation, just simple conversation. I shown number of conversations previously. I see in what way they are always about something like that. You can observe user conversation and that machine conversation like that. Okay, classification of chatbots. Chatbots can be classified into different parameters, including service provided, the knowledge domain, the response generation method, the goal, and the permission and the amount of human aid. Classification is based on the service provided. Consider sentimental proximity of the chatbot to the user, the amount of intimate interaction that takes place and the task of chatbot is performing. Interpretal chatbots provide services like booking services or such as FAQ without being an companion of the user. So interpretational chatbots live in personal domain of the user and are expected understanding user like a human does. Inter-agents chatbots communicate with other chatbots, accomplish tasks. The knowledge domain refers to the knowledge chatbot access the amount of data they are trained upon. Open domain chatbots can respond to the questions from any domain, whereas closed domain chatbots only has a knowledge of particular domain. Classification is based on response generation. Method takes into account method of generating responses. A chatbot is classified as a rule-based, retrieval-based, or generative-based chatbot. Chatbot classification is also very important. This is the very important one. That's what I want to post in the chat box. Rule-based. Okay, a rule-based chatbot. Okay, a generative-based chatbot. Okay, retrieval-based chatbot. This is very important for the examination point of view. You should write all these, highlight all these things. Classification of chatbots. What are chatbots? What are the functions of chatbots? Okay, what are the principles of chatbots? You are in position to write, of course. The classification is based on the goals considered. Primarily, goal a chatbot aims to achieve. Information chatbots provide the user with specific information stored in fixed source. Chart based on conversational chatbots are designed to hold natural conversation with the user, like another human being would do. Okay, so chatbots can also classified according to permissions provided by the development of platform. Open source platform make their code available so that the developers have control over the most aspects of implementation. Finally, depending upon the amount of human aid, chatbots can be classified into human meditated or fully autonomous chatbots. A human meditated chatbots are uses human computation at least one component. Fully automated chatbots fast in processing information, while computation provides flexibility, helpful gaps caused by the limitations of algorithms. The figure shows summarizes classification criteria of the above. Just see that Chartboard categories: knowledge domain, generic subclassifications, open domain, closed domain, service provided, subclassifications, interpersonal, intrapersonal, interagent, goals, informative, chartboard based, conversational, task based, response generation method, rule based, retrieve based, generative, human aid, human modulated, autonomous, permissions, open source, commercial, classification of these chatbots. Design principles. There are two approaches can be used to develop a chatbot depending on algorithm and the techniques, rule-based chat approach and machine learning approach. There are design principles are of two types: rule-based approach and the other approach is machine learning based approach. Rule based approach. The first subclassification first one is rule based approach. A rule based chatbot processes information and provided responses based on a set of predefined rules with the use of pattern matching algorithms. Although the pattern matching techniques vary in complexity, the basic idea is the same. The user input is classified as a pattern, and the chatbot response matching algorithms are handcrafted. Pattern matching adopted in by chatbots, many chatbots, and is especially popular among the early chatbots. Okay, there are example Elijah and Parry and ALIC. And the advantage of rule-based approach is its speed and it does not require any deep analysis of the input text. However, the responses are repeated and lack flexibility and originality as the knowledge is set by the developer in advantage. The following paragraph will provide an overview of the three most commonly used languages for implementation of rule-based chatbots. Artificial intelligence markup language AML is a derivation of extensible markup language. Okay, these are all I am working practically. That's why I'm telling more technical points in a simple manner for both knowledge and to secure a good grades marks of course. This is the was implemented in AML language. AML is a class of data object called AML objects, and these objects are responsible for modeling conversational patterns. Each object consists of two units called topics and categories. Categories are the most basic unit of knowledge and are rules of the chatbot. Each category consists of two elements called pattern and template. The pattern matches against that input from user to the template that consists of response of the chatbot. So flexible and highly maintainable. Okay, so adopted languages for chatbot development. See that this is just like a HTML language. Okay, this code is like this. Model is a simple model, of course. Ruby script, a line-based scripting language, can be compared to AML. Okay, Ruby script, built-in features and tags, which means that the writer does not need a specific information about the chatbot additional configuration files. ChartScript is open source language for developing rule-based chatbots. It matches user inputs to outputs using rules created by human writers in program scripts through a process called dialog flow scripting. Okay, so machine learning. The recent development of machine learning has made it possible to develop more intelligent chatbots. Chatbots adopt machine learning approaches, use machine learning algorithms to extract information and generate responses, and are able to improve through previous conversations. An extensive training set is required for matching learning based chatbots. Two types of models can be used to retrieval or generative. Retrieval based models involve choosing the optimal responses from a set of responses. And generative models Okay, we use deep learning techniques to generate the response. Architecture, just examine the architecture. We describe general architecture, design and develop important parts of each component. A general chatbot architecture consists of 5 components: a user interface component, natural language understanding component, and dialogue management component, a backend component, and a response generation component. Okay, as shown in the figure. You can examine this figure very clearly. User interface, mobile user request, chatbot response, language understanding, message analysis, user intent, context information, response generation, dialogue management, chatbot, action execution, information retrieval, data sources, knowledge base, web URL request. User interface. The user interface allows users to communicate and interact with through a messenger. Applications like Facebook Messenger. Okay, the operation of chatbot begins with user request. For speech-based conversational agents, an automatic speech recognition system will first transform the user's into the text. The process can be modeled as stochastic process, and the desired output is most portable sequence of words. In addition, speech-based conversational agent also. Okay, this explanation to architecture. Architecture diagram is hard, of course. If you have grip on the architecture diagram, we can write all these subpoints in our own. It's not a problem. A speech-based conversation agent also has a text-to-speech. That we discussed all these points in the previous presentations also. But we will write these points as a sequence in the below of the architecture diagram, of course. Okay. Text back to speech after text responses to generated consists of 2 stages: text analysis and waveform synthesis. Text analysis involves normalizing the text and performing pronunciation and phrasing. Okay, analysis and waveform synthesis involves selecting the pre-recorded speech and meets the most requirements. Natural language understanding. After the system receives the user's request, it uses component to extract information from input and produces representation of its meaning that can be used later on the process. NLU generally deals with 3 tasks: dialogues and classification, intent classification, and slot filling. Dialogue act classification deals with determining the function of user's input, or more precisely mapping the user's okay utterance to dialogue type. Intent classification identifies the primary goal of the user. Intent are mainly domain dependent. Slot filling, the final step of NLU, the agent extracts the other necessary details, which when combined to dialogue and the intent to fully understand user request. Example in the table below. Dialogues act classification and intent classification process described below. Set a timer for 10 minutes. Request action dialogue set act. Set a timer intent. Is there any direct flight between so and so place source to destination? A question. Dialogue set. Look up the flight information. Intent. Will be arriving the some place by some so and so time. A statement. Dialogue set. Click that reservation things. Slot filling. Slot filling is the core of NLU and has received the most research attention. Main task of slot filling to extract information from the input to better understanding its meaning. More specifically, slot filling aims to analyze the context of the input by separating the text into smaller units and then assigning unit tags or labels based on their functions and roles in the text. In this subsection, we will describe different models that are commonly used for slot filling. Regular expression is a tool for describing text patterns. Each pattern is specified by a sequence of characters, and each character is either regular character or meta character that has special meaning. Tokenization involve break up a text units into by words, punctuation marks, or numbers. Generally, English words are separated by white space. Tokenizing as English text should be fairly straightforward. There are some problematic cases where the boundaries of words, abbreviations, and are examples of special cases. One commonly used tokenization standard is also known as, okay, that name, some name, we can call some name as a tokenization standard. Okay, text normalization, bag of words, latent semantic analysis, latent semantic indexing, part of speech voice tagging. Okay, name entity recognition, semantic role labeling, the hidden Markov model. Just observe the diagram of hidden Markov model. That's enough. Parts of hidden Markov model representation here. Mathematical equations and the diagram flow. You can observe. Stochastic fine state transducers. Consider NLU as a translation process where stochastic language models are implemented using the fine state machines. The fine state machines are a sequence of words, output a sequence of labels, and they can be either handcrafted coordinated random variables models or discriminative sequence models based on log linear models. The dialogue management component deals with information coming from other components and is responsible controlling and updating context conversations governing the actions of chatbot. Design issues. As mentioned, the DM coordinators other modules encapsulates of the logic of the speech application. This means that very important component in the chatbot framework, and we need to make so deliberative and thoughtful design directions. Okay, the interaction strategy of dialogue system dictate who has control over the conversation. The conversation can be user directed, system directed, or mixed initiative. When conversation is user directed, user takes initiative and the system just answers the user's queries and commands. When conversation system directed, the system has initiative and the user simply responds to the system's queries. State, grounded, conversational control, system, acknowledgement of the user's input and deciding on the agent's actions. Slot filling, system, requesting extra information from the user revolve observe actions. Initiative, system or user, steering the conversation by either user or agent. Context switch, change of the basis premises of the conversation. Finest site-based DM, frame-based DMs, reinforced learning-based approaches, a corpus-based approach, backend, chatbots retrieve information that is needed for performing required tasks from backend and then forward the message to the dialogue management component and response generation component. Rule-based chatbot requires a knowledge base to store handcraft rules. The rules in the knowledge-based chatbot base should be diverse and holistic possible to ensure robustness of the chatbot. A chatbot can also be a relationship database or to recall past conversations. Taking the previous information into account allows the chatbot to communicate in more consistent, precise, and reliable manner. The development of KB is necessary and is essential, but can be very time consuming and depending on as it involves manual work. To overcome this difficulty, developers came up with a way we can build KB automatically from the existing chatbot. There is also a program that can transfer a corpus into a AML. Many times, rule-based chatbots guide the users and complete the KB using users' response. Recently, there has been trend towards keeping the information digitally stored text on the World Wide Web or in other online sources. These language responsibility store information in a machine readable and accessible form. Examples of these knowledgeable bases includes Google's knowledge graph. Typically, these responsibilities consist of subject predictive object triples and are represented by a graphical structure. The nodes indicates entities are the subjects and objects that edges indicates relationship between the entities. The figure shows Firebase related to TV show. Note that nodes, names, and database are connected direct edges to specific relationships. Just observe this tree. Response generation. Once the appropriate information has been retrieved, the next step of dialog system is to determine the content of the response and the best way to express it. The response generation component is responding for generating responses in user understandable format. The RG involving 5 stages of processing. Signal analysis, okay, response generation, RG stands for signal analysis, data interpretation, document planning, micro planning, and realization. Signal analysis and data interpretation are preliminary stages. Input that is in the form of data, such as numerical data in weather predictions, goes through these 2 stages. The signal analysis identifies patterns and trends in data using pattern matching algorithms. Data interpretation uses simple reasoning methods based on domain knowledge to analyze complex messages and relations between the messages. Document planning can be further composed into 2 substages: content determination and discover planning. Content determination involves deciding what information needs to be delivered to the user. The system only communicates some of the information retrieved and it may communicate the information in stages. When necessary, content determination also involves filtering and summarization of the information. The discourse planning is concerned with organizing and structuring the text to aid human comprehension. Micro planning involves coming up with a sentence that deliver the information. It consists of 3 tasks: referring expression segregation and lexical selection. Dealing with referring expression involve choosing appropriate way to address an entity given a particular context. For example, an entity should be referred with a pronoun. It has already been mentioned earlier text. Realization deals with the knowledge of the content. For example, to choose the correct sentences. Enforcement of the subject agreement. Statistical approaches to RG. We are going to review some commonly used language models, models that are assigned probabilities to sequence word. Ngram is the simplest language model. Formally, we write desired output of assigning probability to sequence of n words. We apply the chain rule and the Markovi assumption and the current word dependent only on the previous n minus 1 words. For example, a Gram model approximates the probability of a word using only the conditional probability of the preceding word. We can rewrite the expression above the model. The probabilities are estimated using the maximum likelihood estimation. To get estimate, we estimate the Bigram probability by counting the number of occurrences and then normalize it by summing of all Bigrams to start the word. Recurrent neural network is a network that contains a cycle in the network connections, which means the previous outputs can be as inputs. It overcomes a major drawback of n-gram models. That context the information can be extended limited. RNN-based language models take sequence of words as input and predict the next word in a sequence. At each step, the model first computes a hidden layer using the word embedding or vector representation of the current word and previous hidden layer. The new hidden layer then passes through a softmax layer to generate probability distribution over the entire vocabulary. See this equation. Rn is trained of the text using called the forcing, which minimizes the difference between the probability distribution. However, in practice, RNNs are hard to train because they cannot carry forward distinct information and because of so-called vanishing gradients. Just see the diagram. Long short-term memory is a variant of RNN. It was introduced to overcome difficulties of RNN. This is achieved by explicitly to context layers and specialization gates to control information flow. Three gates are introduced into the architecture: the forget gate, add gate, and output gate. The forget gate is responsible for getting rid of information that is also no longer useful. And the add gate selects new information that is needed for the current context. And the output gate determines whether a piece of information is required for the current hidden state. Each gate is composed of a feed-forward layer or sigmoid activation function and point-wise multiplication with layer being gated. Transformers map into input sequence to output sequence with a similar approach of RNN. At each step given input sequence, the transformer produces an output distribution of overall possible words. However, it does so without the recurrent connections with the use of additional layers called self-attention. Self-attention is the key of transformers. Information can be directly processed without going through intermediate recurrent connections. A self-attention layer takes word sequence as input and output sequence as the same strength. Okay. Encoder-decoder networks are sequence-to-sequence networks are special case of RNN capable of generating arbitrary length output sequence. With the context, an encoder-decoder network has three components. An encoder has a context vector and decoder. Encoder converts the input sequence into a contextualization representation called context. And the decoder accepts the context input to the generated output sequence. Both encoder and decoder are LSTM or transformer models. Encoder-decoder architecture trained paid of strings. Each consists of source and a target. applications of future outlook. Okay, so in this we will discuss about the Microsoft Xylem. We first present the design and implementation of Microsoft Xylem, a popular social chatbot in the world. A social chatbot is a dialogue system designed not only to respond to the users and request, but also to establish long-term and emotional connections with the users. This is the concept here. See this table also, conversations. It's an efficient social media conversation system by Microsoft. Design principle. Okay. As I mentioned, the core of social bot is ability to respond to both instructional and emotional requests. More consistently, it requires both a high intelligent quotient and an emotional quotient and a unique personality. An intelligent quotient capacities are skills that allows the chatbot to respond to specific questions and tasks. These capabilities include knowledge and memory modeling, image and natural language understanding, reasoning, generation, and prediction. Emotional quotient is composed of two key components, empathy and social skills. Empathy refers to the capacity to understand or feel from the another person's point of view. Social skills to involve the framing the responses based on the user's background interests and needs, maintaining the flow of conversation. Personality is defined as the characteristic set of behaviors, combination emotional patterns that form an individual distinctive character. A social chatbot needs to demonstrate a constant personality so that the user know what to expect during the conversation and consequently develop a long-term relationship with it. These objectives fulfill with hierarchical decision making process, which can be modeled a Markov decision process to maintain attractiveness to the user, including charting casually. Okay, so for the other services, okay, and each conversation mode to handle, okay, each conversation modes including charting visually, okay, booking, and each conversation and corresponding skills. A dialogue can be regarded as a hierarchical decision making process. A top level process governs the overall conversation and selects the appropriate skills. And the low level process that generates responses and actions accordingly. The process can be modeled with a Markov decision process, where human users are the environment at each step. A chatbot takes current dialogues, state as input, and output skills are responsive based, and the hierarchy for dialogue policy architecture. This Microsoft Direct based architecture here. See these blocks: full duplex, message based conversation, text image, voice, video, conversation engineer, general chat, domain chat, skills, task completion, deep engagement, image commencing, and content creation. Emphasizing, okay, empirical computing, user understanding, social skills, Zelig personality, global state tracker, dialogue policy, top save policy or skill selection, top manager for core chart, Zelig profile, user profiles, paid database, text image, unpaid datasets, topic index, knowledge graphs. Examine each and every block very carefully. I want to stop here. These so many principles are there. Just examine I'm highlighting design principles, architecture principles, concepts very much clearly in the practical environment point of view. Okay, just try to grasp more and more on this because I'm completely concentrating on the practical world. That's why the reason we should concentrate more. In the next presentation, I will continue the remaining topics actually. Okay, so make a perfection up to this. ఓకే బికాస్ నేను చాలా టాపిక్స్ ప్రిన్సిపల్స్ మీకు డిస్కస్ చేస్తూ వచ్చానండి. దిస్ ఈజ్ ఎనఫ్. ఇంతవరకు మీరు జాగ్రత్తగా అర్థం చేసుకుని నాలెడ్జ్ గెయిన్ చేసి సొంతగా రాయడానికి ట్రై చేసి మంచి మార్క్స్ తెచ్చుకోగలిగితే ఎనఫ్. చాట్ బోర్డ్స్లో మీకు బోల్డ్ అంత సబ్జెక్ట్ వచ్చినట్లు లెక్క. ఓకే, థ్యాంక్ యూ ఆల్. ఇన్ ద నెక్స్ట్ క్లాస్ presentation I will continue the continuation of this. Okay, I highlighted most important things. Try to remember. Once again, I will repeat the concepts in the next presentation. Okay, and then I will continue to the next topic. Thank you all. Thank you.